This is a file name. What is the Etabs model file name? Okay, I got it. First building, huh? No, that's fine. The same file. Yeah. Yeah, Manish bhai. Here. Same file. What Suresh sir has given the same file. Okay, boss, I'm going to run the model. Huh? What is the use of that? What is the use of that? I told you. Before. Center of gravity, center of rigidity is what different. Okay. Yeah. We assigned an electron, but then we connected only to the V's and O's. You removed it from all of the. No, we did not do it. Okay. We did a diagram multiple flaps. Okay. And what it does is, based on the shape of the buildings and based on your natural stability system, automatically CR, center of rigidity, is going to get adjusted. Okay. CR, center of rigidity, is going to be adjusted in the model. Okay. Now, our experience, I tell you, if you do have dual system, 25% of the forces is supposed to be frame element, 75 to 80% of the forces is supposed to be shear. When anybody asks you, what is your lateral stability system? You are in the position to answer what is my lateral stability system in any way. Okay. Either you do villa or G+4, G+5 high-rise building within matter. You should be able to give you the answer that actually what is your lateral stability system. If you don't have shear wall, then you cannot tell like my lateral stability system like it's for two, you're getting two small code, staircase and literature. Is not going to be resist the whole lateral stability system. It needs the huge stiffness. It needs a huge amount of pressure in order to observe the forces. Or else the maximum forces will go to the free methods. Okay. The one of the best example, if you go to one point municipality, the building, the World Trade Center. Go right? All the columns are based. So empty. There is no core, there is no shear. The staircase is built with the block. Because it is not mandatory. And later on, we are talking about the back. Then they said the rules actually civil defense. We need the staircase should be RCC wall. The left is supposed to be RCC wall. It is not mandatory. Staircase actually also it is mandatory. Very important. Since it is a fire exists actually, some of the location of the people are going to stay. It has to be RCC wall. The reason why RCC is going to be behind the fire. At least 2 hours. Other than this, nothing. Okay. You cannot give the guarantee for the block at all. Right. So the CR is going to be based on the lateral stability system. So you are in the position to say, my building, which is going to be covered which kind of lateral stability system. If you don't have shear wall, it is completely frame. All the columns is going to resist the 100% of forces. If you do a shear wall, you need to see what is the mass of the shear. What is the stiffness of the shear? Having one staircase, you cannot say actually I do have dual system. One staircase, along with a huge footprint, or 2 staircases, is not going to take 80% of the forces. It's a column plus shear. Frame elements plus shear wall system. Columns plus shear. See, there are 4 kinds of systems. One is bearing wall system, they're not going to use it. Bearing wall system is typically there is no column, there is no beam. It's a wall and the slab is going to rest on the top of it. If you demolish the wall, slab will fail. This is the bearing wall system. What typically used in our home door. The second one is building frame system. Building frame system, it does not require a shear. If there is a shear wall, it is good. But in a building frame system, it is not. The third one is what? Shear wall system. No difference. Building frame and shear wall, it is a matter of the length of the element. For the length of the element, if it is greater than or equal to 3 times of the width, it becomes shear. It is a matter of the length. 3 times. As per the law, as per A.E.X.L. one. But as per municipality, they ask 4 times. Okay, don't get confused now. As per A.E.X.L. one in 90, it is only 3 times. But the municipality is asking 4 times. Okay. Dual system, 90% we used to enter the dual system. 90%. What happens? In that case, if by default it has to be here. Then the rest of other, it could be as a column or it could be as a shear wall. So automatically it falls under dual system. It's you are not like by force to keep the dual system. Automatically you end up with the dual system. But when the building is slender, when the building footprint is less actually, then the frame or dual system does not work. Then you have to go for shear wall. Okay, because it needs like a kind of lateral stability. The lateral stability should be two ways. One is in X direction, another one is Y direction. Either you are checking the displacement, you check the displacement for two direction. This you check for two direction. So in both sides you need a stiffness. In both sides you need a stiffness. Wind doesn't matter. Wind I can take it. I know where the wind is going to go. Okay. If I do have beams on top of it, ring beams, it's easily because I know the concept. But this is a bit of this is what I achieve. The lack of stiffness, it is exceedingly lack of stiffness. We need to identify where the lack of stiffness will be with respect to this. And which floor the drift is going to be maximum. It is not that actually my drift is being like beyond the limit. I can go like what you call ground floor onwards, taking all the structural stiffness element to be like massive. Or I can introduce it is not going to be like so you don't know the concept.
So we have direct wall, trade means column and beams,
Yeah.
and then shear wall alone.
Then dual
Take that, then dual system shear wall plus
column.
plus column and beam.
See, there is no word called actually it is shear. The core wall is nothing but what the box is close. Okay, the box is boundary. It has to be close boundary reached for core. Actually, this wall is shear. This is a horizontal force. It is also called the shear force.
Shear wall is when we take it for lateral loading or to structural design is shear wall. Other one is like normal core wall, just for lift or something.
See, the core wall, the core wall, it is not a thing.
Okay.
The structurally, there is no word called core wall. When you say the boundary, if it is close, I can use the word called core. Structurally, it is all shear. Structurally, there is no word called core. Technically, it is all shear. The reason why horizontal force, the one which you are talking about, wind RCC, it is also called as what? Shear force. Shear force can be resisted with the columns or it could be shear. If it is building frame system, all the shear force will be resisted with the columns. If it is shear wall system, all the force will be resisted with the shear. If it is well system, with respect to the moments, with respect to the stiffness, the percentage of the shear force will be transferred to the shear wall and columns. It cannot say 50. It ain't. Because where the huge stiffness is there, and there the forces is going to be attacked. Attention. Because easily it's like waves. When the waves comes actually, when it is hit to the building, it movement because it is magnitude. It will be like taking your hand like as close together in one circle, 5 meters. Okay. I'm going to push you. You're not going to fell down because you're going to transfer the forces to it. So someone is going to be like WW he can resist the forces. You may equal sway, but you will not fail down because your forces is going to be transferred. That's what is going to be happening in the building. The building won't happen actually. When the force hits, okay, the column is not going to be because it is acting as a one unit. Then the forces is going to be get distributed, which is the limit of the champion. What is the it has like huge amount of finish. It try to search, and the wall would attract the forces. Wall, see what happened when I'm going to like equal hit to one person actually, all 4 person whoever is weak, they will go. This is what is going to be happening. The building is going to have an oscillation. Okay. So this oscillation is not meant actually it is going to. This oscillation is going to stop because of this. Wherever the stiffness is huge, try to what we call stop this acceleration. And they try to stop the what we call your drift to control the drift. If there is a lack of stiffness, then it matters actually, it goes beyond. It is simple. The concept don't try to confuse. Wind is different concept, drift is different concept. Deflection, deflection is due to gravity. Any element you have a load, you have a deflection. But don't confuse with displacement and drift.
Now, for it, like the meaning design for CP.
What is it?
The meaning design for CP. There is a steel structure. You say it does not require to be designed for CP. For example, major it's there's some. They say it's not required to be for CP.
Kind of debate. Reality you have. Okay. But what happened? If you design it to look like so bulky, that's like architecturally and it would be like canopy or pergola kind of things. Even if it is style, okay, I don't mind because the whole building, the whole design is for the entire self. It's a small canopy. But you need to think that in terms of percentage of the what is going to be covered the steel structure. A small canopy only for the architectural point of view can ignore. This is to map out to save the cost, to optimize this. If you want to consider. There's no way in the code actually you cannot consider any of this. Okay. The code says if you consider for G plus 1 or G plus 2, there is no mass, then you will not have any. But the code says because to calculate this is because you need a mass. When there is no mass, then how could you have an impact on the buildings?
And also for this structure that the coefficient will be different than for this if you take say canopy or any minus steel structure, right? Or you have to same category, same exposure and
acceleration, velocity, will be same. The coefficient is different only to application of the wind.
for wind, but seismic.
The reason why the steel structure, it could be an individual column or it could be curvature. If it is an individual column, I cannot take influence area to multiply to operate. If it is an individual column, then I can only multiply the piece of the columns. Because that is where it's going to be attacked. But the code is a bit of stringent, a bit of conservative. The reason why? In giving what we call the two coefficients. One, the short section is short but actually I beam hollow section, square section. Then you need to multiply the force by 2. So coefficient. Okay. It is a rounded section is there, like circular section. Then you have to multiply by 1. The reason why in rounded section you are taking 1 point. When you are calculating the wind in terms of UA with the dynamic pressure, you are not taking the half of the section, you are taking the full section. So, a bit of conservative actually, they're asking us to multiply
1.2 times the dia or
1.2 times of the dynamic pressure. What you going to come? Remember, we have seen in calculation. The dynamic pressure multiplied by force coefficient multiplied by the factor. Okay, the dynamic pressure which you are calculating with respect to RCC pressure. The dynamic pressure which you are calculating is multiplied by. Okay. Then the pressure multiplied by coefficient multiplied by gas factor. I'm talking about this coefficient, CF. So this it could be varied with respect to individual number or close number. That's all. Other than that, acceleration, velocity, everything. Here, select, go to select. Select object type. Select columns and beams. select close and go to design. Here, concrete frame design. There's option called view revise overrides. Can you see here in second option, if you scroll down, you will get 4 options. What is non-sway? What is sway? First of all, what is sway? When the sway is going to be happen? Due to fantastic. So if there is no lateral force, there won't be any sway, isn't it? So non-sway is going to be applicable when there is no lateral force. Sway ordinary is very similar to non-sway only. There won't be any word called sway ordinary. The reason why there is no word called medium rise building. Either it is what you call small scale building or high rise building. But there is a word called tall building. But there is no word called medium rise building. People, we are using G+6, G+7 medium rise building. How does the difference between small building and high rise building? Only because of the seismic. In UBC 97 actually, it was a clause states that up to 19.7 meter height, you don't need to consider the seismic. I'm talking about UBC 97. Up to 19.7 meters, you don't need to consider the seismic. 19.7 is what? Almost 5 floors. Correct? Almost equal to 5 floors, 5 floor per roof. So that has given the class up to 5 floors, you don't need to consider the seismic in UBC 97. But every country actually, they do have set of regulation, local regulation. So what happened? It's kind of open book. Nobody has an idea. Whenever we used to approach the municipality, even they don't say anything. Someone will say, consider seismic. Someone will approve as it is. Till now. Even up till now. To be frank, up till now. Still, the debate is going on. Somehow it is a bit of clear now. For G+1 building, you don't need to consider seismic. Somehow. But before it is not. You approach different engineer, different opinion. For villas, consider seismic. Why do? Nobody has an answer. Wind is makes sense. Because wind you cannot avoid. Wind is used to. Seismic is going to come in a once in a blue moon. So why should I increase the cost? The debate comes. That is the reason why they release DBC 2021. Dubai Building Code 2021 to mentioning all the coefficient, time period, allowable time period. And what is the site clause you need to consider? Even it has given site clause, site clause B in DBC 2021. If you don't know, consider site clause B. If you don't know. But if it is mentioned in geotechnical report, consider whatever it is. If you don't know, I'm talking about only Dubai. Huh? Don't talk about anything other than outside the country. Only Dubai, what has been given in DBC, if you don't know, consider site clause B. If it is not, then whatever it is specified in geotechnical report, take it. So, read a point. Okay. Now, what is this? Whatever we are going to deal, it's either sway intermediate or sway special. When we are going to use sway intermediate, and rest of all the elements actually, whichever is going to be continue from ground floor till roof actually, all it is sway. When you're going to consider lateral, it is sway intermediate. The reason why intermediate, my building is flexible. My building is not rigid. If you want to design the building is rigid actually, then you should design entire building as a concrete structure. Even block wall also concrete. It means what? You're not allowing the building not even a single mm. Rigid means. Flexible is what? It's a funny example actually. When you're playing the cricket, when you're catching the ball, keeping hand as it is to block and catch it actually, it will be hurt. If you block and take half of it back actually, it will not hurt like before. Because your hand is flexible. The same way what you're going to do here. Until otherwise, if the building is not flexible to just absorb the forces, it will not behave. Then you cannot design the building as an optimum. Okay. The building cannot be as, what do you call actually, rigid. Rigid is what? When there is a client requirement, you need to design the building is blast resistant building. You know the difference? Blast resistant building. Means what? I have a threat. Any time on that location, okay, anybody can keep it over there. You get your point, actually. If that is going to be happen, then my building should resist that impact. Or else I can design the building as flexible. This is mostly it happens like in Ruiz. With whom actually? This oil and gas project. There is a specification was mentioned very clearly. You need to consider the building as blast resistant. Yeah. Then blast resistant is what? If the column comes, say for an example, 400 by 800, it becomes 800 by 800. It's so bulky, so rigid, because it's made up of for blast resistant. You have to. There's no other way. Or else I can design for what? The building should be flexible. Flexible in the sense what? The building is flexible. At the same time, it should not have any cracks and it should be within the permissible limit. And all the structural serviceability check. Understand, no? That's what. Sway special is what actually? It's a key element. What is key element actually? It's called what? If planted columns fail, what happens? Below element also. The transfer beam. Imagine the reverse. If transfer beam fails, then what planted column? Right? But transfer beam fails, the supporting column also. If we did not design properly. If you did not design properly. Okay? So what happened? You have to give and a bit of on a careful approach will design the transfer beam rather than the other. Now what court says, when you're designing the transfer beam, you need to consider the factor of safety in a crystal clear picture. Only for transfer beam. But people are having misunderstood what transfer beam plus planted. You don't need to design the planted column for pointing. The key element is what? Transfer beam. Nobody knows how much transfer element in terms of percentage can I adopt to the buildings. Because why nobody knows? It hasn't given in DBC. It is not from when no, not owing your caliber. Even me also I don't. If under his authority, he will not give me the information, okay. Then when we asked, they said it's 30%. If it is more than 30 to 33% of the entire element, so I do have like 2 columns. You can take it 30 to 35% of the columns as planned. 30% as a plan. More than that, authority will be. They'll ask you, if you do have a transfer beam, transfer columns, do not put it. Sometimes entire columns will become one. Look at the project, which is very close to Muktam, which on the right side, you might have seen there is a 24th hour is going. We left of the polygon because our scope is only for 6 hours. What happened? 4th floor, 2nd floor, all the columns. From 4th floor onwards, till to the 17th floor, all the columns. Entire columns start. In that case, transfer beam is not going to be helpful. You need to make entire slab as transfer. You made it like those slabs is 1.2 meter thick. In 4th floor, imagine. It's elevated raft. 4th floor slab is 1.2 meter thick in order to take all the new planted columns from both floors. Understand what I'm trying to say? Because all the columns is going to stop. Because it's still the footprint actually, the column is literally inclined actually, and I have to take it like new column because of that. In that case, you have to design very sway special. Only for the key element, only for the transfer, only for the transfer, not for the planted columns. What is the difference between planted and floating? Function is same. But in terms of reinforcement, if there is any difference, planted column and floating column, function is same. That is also new column. This is also new column. What is the difference between planted column and floating column? Well, look at the English terminology. Planting, right? You are planting the trees. How do you plant the trees? Like roots, right? That's how you are planting the columns. Like L bar. If you're taking the columns in the wall, either in shear wall, either in retaining wall, are you going to take the rebar till to the foundation? Imagine till fourth floor, I have a shear wall. From fourth floor onwards, column is going to start. It's not necessity like, I can use the same rebar. Even you can plan the new rebar, right? Maybe instead of 10, I have to go for 13 rebars. And 3 rebars, you have to like, add it. Correct? So why don't you take this 3 rebar till to the foundation? You're not doing, right? You're doing this. And what you used to do, you will take only 50 times of diameters, right? So the bar is floating, right? Now I'm telling the terminology. The concept of floating column, planted column is both are same. But when you talk in terms of like, reinforcement details, it be different. The floating column, you're only taking like, lap length. Like planted column, you have to take it to the base. If it is slab, then you have to take it from the slab, like L bar. If it is beam, then you have to take it like, L bar from the beam. Differs how they are designing it. If the designer has released this column, as a pinned support actually, you can consider this column as floating column. If he did not release, then you will have a fixity. You will have a moment actually. Then it needs some kind of like, base to transfer. Then if the beam is even 1 meter, I need to take this column from the bottom of 1 meter actually. If the slab thickness is 300, I have to take it L bar from 300. But floating column, if I release actually, it is a pin joint. There won't be any moment. Then I can take it only lap. Whatever 40D, 50D, 60D. I'm not coming to the picture. But whatever the lap which is mentioned, it is more than enough. Because there won't be any moment. You understand? No? Try to understand the concept, technical concept. You may say, I'm not getting the Etabs model actually from consultant. That's a different story. Okay. But if any argument comes like this, now most of the contractors are getting Etabs model. I'm sure. What happened? Any kind of clarification, queries actually, contractor is very smart. The first thing actually they're getting the Etabs model. Within 1 month, 2 months. The consultant is not refusing now. You have to. Because in order to extract the forces or in order to say anything like, they're giving the Etabs model. Before, they were not giving. Then you can check in the model actually, whether he released or he don't release. If anything like, goes in the mistake in the site, say for an example, you haven't taken the column down, and you can check the model. If he released, then you can have a debate. I've checked the model and the column is released and it is considered with this free of movement, then why should I take it? If in case if site guys are doing the mistakes, something like, it's a kind of, then you don't need to like, remove all those things to repair it. You know how difficult it is, right? Once the bottom bar is placed, chair bar is placed, the top bar is going to lay. If someone is going to come and say, I need to put extra rebar at the bottom, it's not that easy actually. It's not a magic. You need to remove the top bar, you need to remove the chair bar, you need to go and add the bottom bar. Actually. It's not easy like, the people can go like, it's easy. Until otherwise, if it is a massive raft, massive thickness is there, people can walk and people can add it. Actually. If it is like, less thickness, 1 meter, 1.1 actually, it's very difficult. People can go approach. And nowadays, you will say like, it's a more conservative design. You're getting like, 3 layers, 4 layers, 5 layers, 6 layers, 7 layers. Actually. You're getting a point. Actually. The reason is the two kind of things. You might have seen the manual calculation, the column capacity when you're calculating. It is the combination of two, concrete capacity plus steel. Okay. Even if you don't provide the steel, you still have the capacity. The concept is what still you have the capacity, but it is very less, but still you have the capacity. Means what? The people are on a new, fresh design. Actually, people are like and with of lack of concept. What they used to do, even if it is demand another 50 millimeters of concrete thickness, they don't want to do that. Instead of actually, they are increasing the reinforcement because they don't bother about the cost of the reinforcement. They don't have any idea. Concrete is much cheaper than the reinforcement. The lack of this knowledge, people what they used to do, whatever I have given the information to architect, actually I cannot go back and change. That's it. Then I will play on the reinforcement. You see sometimes 6%, 7%, 7.5%. But this could be solved in a two ways. One is either you increase the grade of concrete or increase the column little bit. What happened? There are two ways. People are hesitating to talk to the architect or lack of knowledge. You get what I'm trying to say. Yeah, go to Sway Intermediate. Okay. Design. Concrete frame design. Again. Start design check. Yeah. Start design check. ये लैपटॉप है लैपटॉप है ना वंडी सर्विस को तो मुझे चल रही है Okay. Select object type, columns, beams, select closer, then go to design, concrete frame design, view revise overrides, Sway Intermediate. Okay. How many of you know this? How many of you know this? No, I'm not telling you. No, I'm telling you, fresh designer actually. They're blindly using the Etabs model. The Etabs model is giving the result. If it is fails, fails. No, we have seen in the manual calculation for calculating the K value, right? Fixed to fix, fixed to pinned, pinned to pinned, and cantilever. You can change this. You can change here. What happened? Instead of 1, I can go for 0.9, 0.8 if it is fixed, because my all columns is fixed. If you change it, my column is going to pass if it is failed. In the marginal case of 10%, 15%. If it is fail in a huge demand, that is a different story. You don't need to increase. You get what I'm trying to say. How does the software will understand? Software is made up of only for tool to help you to create the model. This is not the AI tool actually. If it is AI, then it does not require your presence. Point. And you have to use your technicality to change it. You get what I'm trying to say. What is 1? Is pinned. 1 is nothing but pinned. But in reality, it is not pinned. In reality, it is fixed. You can still reduce it. If you reduce it, then column effective length will get reduced. Then it demand less reinforcement. Point. Okay. All the columns, what does people having misunderstood that if the column is connected to the beam, then it is called braced column. Very important. The column, if it is connected to the beam, it is called braced column. If I do have only one direction beam, then my column is braced only one direction. Other direction, my column is not. Who said it? Your slab is also giving the braced. Your slab is also giving the braced. There is no slab, it is to make difference. The slab will never allow the column to crack at the junction. The column also, if it is try to buckle, it will buckle in the middle. It will have a rigidity at support. Okay. So in that case, the effective height will be bottom of soffit of slab to the top of slab. Soffit of slab to the top of slab. If it is a beam, it is an added advantage. My effective length is going to be reduced further because of the beam depth. If my beam depth is 500, then my column is going to be like, lesser height. If it is not, if it is a flat slab, then my column height is going to be calculated from soffit of slab to top of slab. So don't have this misunderstood concept is braced, unbraced only because of the beams. Braced, unbraced actually, if it is won't be any kind of stiffness to connect the column, then you can say it is unbraced. Even if the slab, it will give you the diaphragm action in order to give you the stiffness. Getting a point actually. Go to design, concrete frame design, start design checker. Yeah. Go to design, concrete frame design, display design information. Yeah. Change it to general reinforcement details. General rain. This is how you need to read the results. Okay. Okay. You can increase the text going here. Option, graphic preferences. Then increase the text. No problem. Yeah. Not going to look at the because the big. Let us go on the beginning. Right? What? Rigid. Rigid. Moment is going to stop here. No, anybody can read this. In a simple way. Okay. Open the Excel sheet. Okay. Okay. Right. Okay. Overcame late. This is the area of the rebar, right? Yeah, okay. Sorry. Okay. This is the area of the rebar, right? Pi d square by 4. And this is the practical spacing. Huh? What is the maximum spacing as per code? Huh? Maximum spacing as per code is 300. You cannot increase this spacing. Either it could be stirrups, either it could be column rebar, either it could be slab, everywhere. Not more than 300 millimeters. 300 only. The maximum rebar spacing is 300 actually. Additional rebar, you are going to place it in between only. Then it's going to be reduced only, right? Actually. It's not going to be increased, isn't it? But the main mesh is what do you call 200 only. No? Additional is okay, but main mesh is 200 only. That is one. No one is going more than 200 millimeters practically, right? Okay. So I told you, what does it mean? T12. Yeah. What does it mean? In slab, if it is given 12 mm dia, 200 millimeter spacing, which we need to provide only for 1 meter. Then regardless of the span, I will continue. Right? This is for per meter. So why I'm trying to say per meter, designer will design only for per meter. That's what I'm trying to say. In site, you will understand that actually I have to provide. Yes. But designer has done the design per meter. That is the reason he mentioned T12 at 200 mm center to center. Regardless of the length, you can continue. It is fine. So for 1 meter, if I go for 100 millimeter spacing, 10 rebar. For 1 meter, 100 millimeter spacing, right? In similar way, yes. Yeah, okay. That you don't need because you are calculating +1 at the end. I'm talking about in general in middle actually. Usually +1 will be taking actually in the end location. +1 will not come everywhere. Okay. And T8 at 100, what does it mean? The area of the 8 millimeter dia multiplied by the numbers. So 50 multiplied by 10. Correct? Yeah. Dia. Right? Yeah. Yeah. Okay. And this is the rebar requirement, right? Yeah. Okay. Okay. The first one. Okay. The first one is what? Is the stirrups area. The first number is stirrups area at left support. The second number is stirrups area at right support. Shear where it will come? Only at support location, right? Moment will come at the mid portion. That is the reason you're having the closer stirrups at the support area, right? At 1/3. 1 by 3rd LHL. The second number is what? Second number is top rebar. The top left, top middle, and top right. The first number 0, 0. Imagine there is like 100, 200. Okay. The first number is left support shear here. The second number is right support shear. I'm only talking about this beam. Huh? I'm only talking about this beam. Yeah, 1/3 actually. The second number, all three number, it is for top rebar. All three number, it is for top rebar. In second number, second line, the first number representing top left, top middle, top right. Can you see the middle? 195 millimeter square. It means there is no moment. It's only minimum steel is shown. I've taken story 4. The third number is a bottom rebar, bottom left, bottom middle, bottom right. Third number. The fourth one, this number 1369. It's called torsional shear. What is the difference between vertical shear and torsional shear? When you do have a side face reinforcement, regardless of the minimum rebar, what is there in the code, when it is required side face reinforcement, regardless of torsion, you need the side face reinforcement. Yeah, that is fine. That is code. I'm asking another question. You have vertical load, right? Gravity load. The beam will behave vertically. You'll have a moment at vertical direction. Correct? When it is lateral force, how does the beam will behave? Then it goes to there's a torsion, right? You are very close to not having to compensate here, I need to have bottom line. Wherever the moment, right? And if this moment goes, then I need a top line. If this moment goes, I need a top line. And here, there is a movement. Similar way, if it is very like this, to compensate this, I need the face range. Side face range. This is my beam. This is the rebar. If this rebar, if it is very like this, the thing is going to be like this. If this rebar is compensating this moment, lateral moment, then you don't need any side face reinforcement behind this. But as for core, if they are still more than 700 millimeters, then I have to go. That is the difference. That is the new side facing. More than 700. But here, the design point to know is this rebar or this rebar additional. If it is compensating, then I don't need anything side facing. Because this side face is going to be captured the lateral moment and torsion. Both. Side face is going to be carried two things. One is lateral movement, other one is torsion. These is not going to participate in torsion. Whatever the rebar in middle. Whatever the rebar in middle is not going to participate in that. It means The face is need to be capital bilateral. If you want to know this, people are misunderstanding the concept is what they are ignoring this key. The concept is what? This is not what this concept everyone knows. But another thing is what? People are missing this data. Whatever the site phase it shows, I'm ignoring this and I'm going to provide the site phase reinforcement here. And it becomes like instead of 12, it becomes 16, it becomes 20, it becomes 50. Because you have a lack of function. And you don't know when the moment comes actually this rebar also is going to work. Interesting. When you say this is the vertical shear line, this is the shear line, right? This is the shear. I'm going to provide these steps here, right? I don't need any steps in middle, to be honest. But for the purpose of confinement, I have. If I don't provide the steps, the bar will open. There won't be any shear. Technically, design pointing off, I don't need any kind of steps. But I have to provide a practical point of view, the bar will open for the purpose of confinement. Right? Design point of view, I have only shear here. If you agree this, then you have to agree the lateral shear. Lateral shear, which is called torsional shear. The torsional shear is the one which is here. 1369.98, it is for torsional shear. It is 0.0, it is called vertical shear. Why it is 0? The concrete beam, it has enough depth to cater the shear. There won't be any additional vertical shear reinforcement is required. In that case, we can go for minimum diameters with the minimum spacing. And you can go for it. 8 mm there, 200 mm spacing, you can go for it. Depends on the rebar. If you go for 40 mm there, it is not available to go for it. You can go for 10. Because you need to mind it. I'm talking about in terms of practical. But core, you can go for like no minimum. Because there is no shear. It is not required. Last one is what? It's called side face bar. Side face bar, not for one side. For whole beams. Two sides.
So we discussed about that, side face bar, right?
Yeah. And fourth floor, maybe I'm using some other model. It was like a small drone, right? What is called actually?
Small landing.
Small, two people can see it. Actually, it was crashing. In Brazil, both of it. Pilot and they told me 6 months back actually, whatever I learned, the money I invested all medicines. The three of them, one is going for doctor. Again, the same university in UK. It's very expensive, I think so. The university.
Either values count it's no
I'll show you now. So related run, huh? Here, can you see here? I don't know this value is going to be like, under which combination, correct? And I don't know what is the moment and what is the torsion shear, what is the vertical shear, what is the torsion moment. Okay. Select this beam, right click, yeah, go to details, yeah, can you see here? Here, look at it here. Which story? Forget about the beam number actually. And section sizes, which combination? I don't know who selected this combination event. It did not use for the editable. Okay, this is the combination, huh? And this is the length of this beam. And what you have designed. So intermediate. Coming to the next point, it's showing the effective depth actually. 900 is your overall depth. And this is the effective cover. Yeah. Coming back to the third one, it's a modulus of elasticity, grade of concrete, grade of steel. Coming to the fourth one, these are the reduction factor as per the ACA code. By itself, it will take. Coming to the fifth one, it shows the moment, top moment and bottom moment. Yeah. And it shows the axial force as well, PU. Okay. And it shows the area of the rebar, which is negative rebar, positive rebar, and minimum rebar. Yeah. And coming to the next one, shear force. See, allowable shear is 297, actual shear is 205. So no shear reinforcement is required. So shear reinforcement is 0. 297 is allowable shear. Actual is 205. Coming to the last one, this is the torsional moment. Okay. The allowable torsional moment is only 21. The actual is 126. So it needs the torsional reinforcement, the net value. And this is the rebar for torsion actually. It's clear, right? And going to the next, see, this is related to torsion. Now I need the diagram. I need the diagram here. Go to display. Go to display. Force stress diagram. Frame pier. Right? Which combination is governed? It's not there. Huh? I don't know whose model. Okay. Okay. Go to display. Okay. Go to display. Force stress diagram. Frame pier. Select the corresponding combination here. Huh? Boss. and show values. Yeah. Then click OK. Yeah. Okay. Still. Select this beam. Right click. Select this beam. Right click. It shows the corresponding combination. What is the shear? You can even what you call scroll down. You can scroll these values. What is the maximum shear at this location? What is the maximum shear here? What is the maximum moment here? What is the maximum moment? And what is the deflection of this beam? Huh? Main important, huh? The deflection of the beam it shows here. Yeah. Either you read it in the details or you read it in the graphical input, whichever is easy for you. Can you see here the practical moment, the one which I say, stopping face of the column? Okay. Just try to understand the concept. I'm not using the same model. Huh? Okay. Okay. This is my beam. Huh? Okay. Fantastic. What is the beam dimension here? 400 by was here. Try to understand the concept, which is more important. Huh? 400 by 900. How many rebars can able to accommodate? I'm going in a reverse way. Yeah, reverse way. How many rebars you can able to accommodate in 400 beams? Because you need the clearance between the rebar at least minimum 60 millimeters to put your vibrator. There are two vibrators, right? 40 and 60, isn't it actually? Needle, right? 25 also is there. But are you using 25 in beams? Ah, okay. So in general, you're using 40, right? So if you want to use 40, at least minimum 50 required. 50 to 60, isn't it? So consider the minimum bar spacing, it required 60. As per code, the bar to bar spacing is required only 2 times of aggregate size, the minimum spacing. But does not work actually. Now it is contradicting. You're getting a point actually. Vibrator actually. Whatever it is, if you're using chips actually, if you're using 20, then it becomes 40, right? 40, you cannot use the same vibrator, isn't it actually? So so what I'm trying to say, the code is only guidelines. So you don't need to follow exactly, whatever it is there in the code. In a several places, code is saying it's as per the engineering judgment. So many places, this is the word is there. As per engineering judgment, you can change it. And these are the places. I cannot follow the code as it is. You get a point. Okay. Now I can go for how many rebars? Which is Okay. Yeah, 4 rebars. The similar way, Allah 4 rebars. Okay. Yeah. Okay. 4 rebars. Yeah. Now look at this. It's a continuous beam. Huh? It's a continuous beam. What is the bottom reinforcement? 767, 791, 825, right? Okay. Let me take it. See, there won't be much difference. 791, 825, there is no much difference. Okay. So I'll go for 825 divided by 4. I'm going to reverse calculation. Huh? So 206.25. What is the rebar which is 206? 16 millimeter dia. 5 millimeter square does not matter actually. So 16 millimeter dia, which I'm going for how much? 4T 16. Yeah, straight away. Usually what happens, the designer, whatever the rebar which is going to provide at bottom, they'll try to provide on top, the continuous rebar. Okay. We'll go 2 ways. I'll go for 4016. And looking at the top rebar, 987, 879, 1036. It's almost very close. So the maximum is how much? 1036. Okay. So 1036 minus 4T16, right? Correct? The area of the rebar for 16201. 232 millimeters square, isn't it? This is called what? Extra. And I can divide by 2, which is 116, which is closer to what? 12 mm there. Then I can go for right below correct? Yeah, only here. Let's say I don't want to go for 4016. I'll go for minimum 4012. Yeah. So 4012 is how much? 113, right? Which is 452. What is your required area? 825. The bottom. 825 minus 452. 373. 373 divided by 2, 186. Again, 186 falling under what? 16. Okay. And what I can go for? You understand the concept, no? If you want to optimize the rebar, go for minimum diameters. Go for minimum diameter. And go for 40. No. And go for 40 for the second option. This is option 1. This is option 2. And go for 7. Yes. Right. No, one. Conservative. Or you want to optimize the rebar, you can go for like a minimum diameters and rest whatever the extra comes at you, compensate the minimum part. There is any application, please do us. Look at the bottom rebar. Bottom rebar 791, 767, 825. If there is a huge difference, you don't need to follow the maximum. If it is a huge difference, then I can separate it, these two beams together, and the last beam in a different diameters. Does not matter. But since 791 and 825, there won't be much difference. So I took it like 825. And 825, I can accommodate 4 rebar, which is option 1. 825, which can accommodate 4 rebar. This is 206, which falls under 16 millimeter dia. Directly, I can go for 40-60. Full length of rebar, continuous, no extra, nothing. If I don't want to go for it, I'll go for option 2. I will go only 40-12 and full length, which is nothing but what 452 millimeters square. And what is the required area? 825. So 825 minus 452. This is the extra bottom, right? Extra bottom. Then I'm deciding to go for 2 rebar. Yeah, 186, which is again 201. And I'll go for 2 rebar as an extra as shown on the board. 2316 at the middle edge. It's clear, right? Okay. Now I'm taking the maximum value. Because there won't be any much difference. Look at it 791, look at it 825, there won't be difference. Third line is the bottom, third line. Third line is the bottom rebar. Bottom left, bottom right, bottom middle, bottom right. Okay. Okay. Correct. Fantastic question. Fantastic. This will not come like, always. Okay. In some kind of beams, actually, you will have it when you do have like, what you call lesser beam, when the minimum reinforcement actually is demanding more. In that case, the bottom left and bottom right, you need to compensate the straight rebar. The continuous rebar, it should compensate the bottom left and right. The extra I can play only in the mid, because the left and right, it is continuous span. You get what I'm trying to say? I'm getting only 328. What I'm going to provide 4T12, 452. This 452 is going to be compensate my 328, 302, 342, 331, 317, 3141. Because 4T12 is more than what is required. Correct? Even if I go for 4T12, it does not require bottom left and bottom right. I can provide, but that's not the usual practice. The usual practice, it is not the one which is providing bottom left and bottom right. No one is going to do this. Here we are talking about 40-16, right? You can go for it, but again, like, what do you call? Keeping the 400 millimeters, at least minimum, keep 4 rebars. If you keep 3, then it looks like, the space is huge. Okay. 200, how you're keeping 2 rebar. 252, and in some cases, I can accommodate 3 as well, actually, if the diameter is less. And 300, 3 bars. 400, 4 bars. Keep it, actually, it looks like, the practicality, I mean, you did not do any kind of mistakes. When the contractor sees, actually, they'll always find to try the mistakes. They will say something is missing. They will raise the RFA. Actually, it is not a mistake. It's a designer vision and a wish. You don't want to go for 4 bars, you want to go for 3 bars. The minimum 20 millimeters is required, actually. From layer to layer, actually, minimum 20 millimeter. Okay, minimum 20 millimeter. The question is, if you go for second, third, fourth layer, your effective depth is going to get reduced. Then you're cheating the model. In the model, what the effective depth is mentioned, 56 millimeters is the effective cover. In second, third layer, then your effective cover is not 56. It's going to reduce further. It's going to reduce if it is going to increase, actually. If it is going to increase, then effective depth is going to reduce. When the effective depth is going to reduce, the area of the steel, which is equal to m by 0.95 FO is Z. Remember the equation. Z equal to 0.89 D effective. This D effective, if it is get reduced, AST is going to get more. The demanding of AST is going to get more when the D effective is going to get reduced. When the D effective is more, the area of steel is less. This is with respect to effective cover. When you're going for second and third, second is okay somehow. When you go for third layer, fourth layer, actually, the municipality asks you to consider what is the extreme layer which is there and calculate the effective cover, change in the beam properties, change the effective cover. Instead of 56 millimeter, put it 150 millimeters or 100 millimeters. Because you increase the number of layers, where it is going to be having much impact in draft, usually. In beams, quite often we used to use, when there is like, huge beam depth is there, then we'll go for second layer, third layer, fourth layer, when the beam length is more. It is 10 meters, 15 meters, 20 meters, then you demand like, huge reinforcement. But it often, in draft is going to be quite often. You'll have 4 layers, 5 layers. Then obviously your effective depth is going to get reduced. So at that particular location, when you're going to check the area of steel, you need to reduce the effective cover. But practically, it does not have any impact, even theoretically, because you do have a lot of factor of safety, so many kind of things. So someone who want to what you call punch you, then they will ask you, reduce the effective depth, increase the effective cover. I wanted to see what is the required area of steel. I wanted to keep more precise, or else it does not affect anything. Only it's a localized area. It's a FEM method, finite element analysis. The whole plate is going to be withstand. When you're talking about flat slab, the moment is different than the one location to another location. The flat slab is different concept than the frame element. The frame element, you do have a beams. Then you can say directly it's a one-way slab and two-way slab. When you're talking about flat slab, it is not the same concept of frame. Because flat slab, the moment is different actually. The behavior of the slab is different. Getting a point, right? Getting back to fourth value, 1369.68. Imagine I do have first value is 0, 0. Instead of 0, imagine I do have 100-200. Yeah. And the second value is 987, 195, 879. Third value, fourth value, okay. And the number 1369 is what? It's a torsional shear. The shear reinforcement in the beam, it is only ties, right? The ties, it need to withstand vertical shear and torsional shear. I cannot provide a separate ties for torsional shear. Whatever you are going to provide the shear reinforcement, it has to withstand the vertical and torsional shear. So here the maximum shear is how much vertical? 200. What is the torsional shear? 1369. What is the total shear? This is the total shear, including vertical and lateral. That is the face bar. 3075, it is the face bar for the lateral moment. Shear, it is only links. Shear, it is only links. Torsional moment, which is lateral moment, next to the lateral moment, beam will twist. When the lateral force is acting, it's a torque. Because two ends is fixed, right? Actually, the beam cannot rotate freely. The beam, what it tries to do, then it will twist. Those moment is going to be catered by the face bar. Torsional shear. Ties, but torsional shear. Yeah. Correct. Exactly. Space bar. Irrespective of the lateral moment, lateral force. That's what I told you. When you agreed, when you have a vertical load, the beam will have a vertical moment, right? If I do have a lateral force, then beam will bend lateral. If you agree this, then you have to agree this as well. Correct. Top. Yeah, but keep it the word called torsion, then you will get confused. Face bar. Yeah. You will not get it. You will get the minimum values actually. Minimum values. Yeah. Torsional shear, it's for throat actually. Can we go for it? Okay. What is the value you're getting? 1569. How many legs in the beams? Now currently I do have two legs, right? One this, another one this, right? It's two legs, right? It's carrying the rebar. If I'm going to introduce this is four legs, right? So four legs. Fantastic. If I go for four legs, then the area is how much? 392.25, right? If I go for two legs, how much? 784.5. And this is for two leg. This is for, it's clear, right? Only divided by 2 divided by 4. If you're going for 784.5 for two legs to match here, don't go the shear not more than 10 millimeter. It's not advisable. It's not recommended, is different. Advisable is different. You can go for it. But people will think actually you've been like, did a conservative design. Try to reduce the spacing, try to increase number of legs, but don't go more than 10 actually. Okay. But if in some cases required, it could be like, substantiable. But if you're going for like majority of the beams is like this actually, then for sure 100% you're doing like conservative. So 784, it's matching here, T10 at 100 millimeter, center to center. If I go for two legs, if I go for four legs, 392.25, then I can directly go for what? T8 at 125 millimeter, center to center. But don't go more than 10. Yeah. It's clear, right? Okay, going with the phase bar. Going with the phase bar. In the first option, I do have 16 and 16, right? First option. I don't have any extra reinforcement, right? 16 and 16. But in top, I do have extra reinforcement. 12 millimeter dia. So in phase, correct. So what is the required phase rebar? $3,279, right? Yeah. So 3,279. And what is one side? 1,639.5 per side actually. And what is the rebar which you do have in phase? 1T16 at bottom, 1T16 at top, 1T12 extra rebar. So 16, 12. I do have 515 already. 1,639 minus 1,124.5. It's your phase bar per side because I've already divided by 2. Okay. Imagine I can go for like 6 bars. 187. Again, it required 16. Okay. If you increase the number of bar, then it goes reduce the diameters. It's up to you, like what do you call with this between the spacing actually. It should not less than 300 millimeters. The maximum spacing is 300 actually. I cannot go more than that. Okay. So you can play around, you can keep your phase bar. Understand what I'm trying to say? Because the phase bar is going to place only in the between. You cannot take it like overall. Taking the overall depth minus the clear cover minus stirrups minus the bar. What is the remaining spacing which is there? Then I can divide by number of. It's clear, right? Okay. Lateral and torsional combined. Imagine when there is a torsional moment is there, when there is a lateral moment is there, the whole beam will bend, right? Whole beam will bend, right? Okay. Whole beam is going to participate. Imagine there is a torsion, two end is fixed actually, whole beam is going to twist. So whatever the required rebar which showing in the model, it is for the whole beams. Whereas I do have two sides which is going to be resist. Get a point? How you are going to divide by the walls. In wall reinforcement, you do have two side vertical reinforcement. Whatever the model it shows for whole wall, you are going to divide by two. Open the model. Let's go for wall design, then we'll go for column design. Huh? Wall design. So let me just go for the elevation B. The good thing in Etabs, what happened? The moment when you create the grids, automatically it will develop the elevation. Okay. So in this grid actually B, if you want to see the elevation, there is a wall, there is two beams, two columns, right? Automatically Etabs, with respect to grid lines, it will create the elevation. How? Can you see my cursor? There is an option called ELEV, elevation. Click here. B. Okay. Yeah. Okay.
When we are doing the concrete design, it will show red for beams. Very important.
Okay. Is it showing red actually?
No.
No, it's not showing. Okay. Let's say like if the beam design is showing red color. Okay, red color. If it is fail under shear, what you are going to do? If the beam fail under shear. If the beam fail under flexure, what you will do? This is what the concept. When the beam fail under shear, it demanding number of legs. The legs you cannot provide until otherwise you will increase the width. You get a point. The beam fail under shear. If you are misunderstood the concept, if you are trying to increase the depth, then even if you are ready, if you are increasing twice the width of the depth, it will not satisfy. Because the problem is under width. There, even if you are increasing 25 millimeter, it will pass. Because it is a matter of width. In flexure, if you're trying to increase the width, even 100, 150, 200 millimeters, it will not pass. Because here it is a matter of moment of inertia. Here it is a matter of the stiffness. The store stiffness, where exactly you're increasing, actually it matters. You may say, even I'm increasing the width, it is also stiffness. No, because the load is acting on the vertical actually. Then it directly go for D effective. Point actually. So until otherwise, if you're not increasing D effective, which is overall depth actually, then it will not satisfy the flexure. So B, yeah, go to design. Sorry, yeah. Leave it. I'm reducing the texture. Yeah. In order to design the wall in Etabs, you need to give some kind of ID name, pair ID. Okay. Then the Etabs will understand you're instructing the command is called to design the wall, or else Etabs doesn't understand. This is only to matter of the Etabs, not in terms of technicality. Yeah? Only for the Etabs. To design the wall, you need to give some ID name. It's usually is called what? Pair ID. Pair is nothing but wall. Pair ID. Actually. Don't think pair is nothing but like the bridge pair. Here, the pair is nothing but wall. So what I'm going to do, I will select the entire wall here. Assign shell pair label. Yeah. Modify show definition. I'll give us W1. W1. Add new name. Anything you can give. K1, C1, D1 doesn't matter. I'm giving since it is a wall. I'm going with the same wall ID. Okay. Okay. Yeah. Previous selection. Design. Share wall design. View revise peer overrides. Make sure the grade of concrete is correct. Then okay. Then design. Share wall design. Share wall design. Start design check. Yeah. Then here clear selection. CLR. Yeah. I'll tell you easy way to read the results. Go to design. Share wall design. Display design info. Pair reinforcing ratios. Yeah. Okay. Okay. Fantastic. Now, if you move your cursor, can you see here? It shows the percentage of reinforcement, right? Right? Okay. So what I'm going to do, so take this. Okay. Yeah, okay. Okay. This is the wall, right? Okay, this is the wall. And this is the horizontal reinforcement. And this is the horizontal reinforcement. And this is the Okay. This is the okay. What is the wall thickness? 300 millimeters, right? You're going to design the wall is what? Per meter, right? 1 meter. And what is this? When you open the Etabs, if you move your cursor, it shows 0.25 percentage. Okay. So 0.25 percentage for the entire wall. Wall, you do have two sides. You do have two flexural reinforcement, right? So 0.25 percentage divided by 100 multiplied by the gross area. The gross area per meter. So 300 multiplied by 1 meter, 1000. And this is your area of the steel, which is vertical reinforcement, millimeter square per meter. This is for two sides. Then I'll divide by 1, which is 375 millimeter square per side, right? Don't go, the main reinforcement should not be less than 12 millimeter. Main reinforcement. If I'll go above, it's T12, T12 at 200 mm, center to center, which is 565. What I am getting is 375. So the vertical reinforcement T12 at 200 mm, center to center. It's clear, right? And opening the Etabs, I need to see the shear reinforcement, which is horizontal reinforcement. Design, shear wall design, display design information, change it to pier shear reinforcing. Zoom this. How much you are getting? 750. You click this wall, right click, you may get the details here. The same how you're getting like details in the columns. What is the axial load? What is the moment on the columns? What is the shear on the columns? And all the details you will get it here. So shear is getting 750 millimeter square per meter. Again, and divided by 375. 375 shear reinforcement don't go more than 10 millimeter there. So if you go for shear reinforcement, 375, 10 will be T10 at 100. It's clear, right? Here it is not cost of food and food. It is not the food. Don't get me. No, what is the name? What is it? What was the new rate? What's the rate? Minimum percentage of the columns is percentage. 0.1%. Column. Lab. 0.1. Why not 2% of the gross areas divided by 2 of
So this is not the same, even area is not the same. This is different from. Sometimes this is created with maybe change that to.
For example, you have bus. You have 19 story, huh? 19 story. The segregation in general without looking at the design, what people use to design actually. If it is 19, every 5 floors, every 6 floors, they don't. That's the design of cross section. If you want to go for an optimum way, okay, you have the reinforcement. Take an example, if I'm getting 1,000. 1,000 is in which floor? Maybe it's only for 2 floors. Then I can separate the reinforcement. From second floor onwards, if it is 900, till 2,000, I can go for second division. If it is 4th floor onwards, if it is on, clear, right? Yeah. To design concrete frame design. Yeah. Display design information. General reinforcement details. Yeah. What you are getting is for columns. Yeah. What you are getting is for columns. The 418 is for the vertical reinforcement for the columns. The second number 00 is the shear reinforcement. Okay. Shear reinforcement. What I'm going to do, I'll click this column, right click. And go to details. Now I wanted to tell you why shear reinforcement is not required. Huh? The column has huge shear. Can you see? 972 is allowable shear. The actual shear what you're getting is 2.9, 4.9. That is the reason it's showing like, zero reinforcement is required. Shear. When you're taking for the columns, the moment is the minor axis and major axis. Here there is no minor and major because circular column. The moment in all the direction is same. So can you see the moment is same? The rebar is required in terms of axial force with respect to the moment is 4418 millimeter square, which is 1%. Yeah. And these are, that what is the column dimension, what is the modulus of elasticity, what is the reduction factor. How much reinforcement? 4418, right? So I'll take the snapshot. Yeah. What is the column dimension? What is the column dimension? Fantastic. So 750 millimeter dia. And what is the area required? 4418. What is the perimeter actually? Minus 40 minus 40, the clear cover. So 750 minus 40 minus 40, 670, right? What is the perimeter? 2 pi r, right? Pi r. The perimeter is 2.1 meter, isn't it? Yeah. Imagine every 300 millimeters. Okay. I'm going the rebar. So 2100 divided by 300. 7 rebar I will get it. Correct? Yeah. This is the maximum possibility switch. But I can go for even 100 millimeter spacing, 150. You get a point. Calculate by yourself how many rebars which is going to get it. You need to know what is the length of the columns, especially for the Here you don't have any problem for the weight. Here you don't have any problem. Very good. Please open the Etabs. Go to any plan view. Yeah. Go to file, export. Yeah. Export, story as safe V12. Story as safe V12. Select any slabs, but tell me which slab you're going to select. No, any slabs. Okay. There are three options is here, right? Okay. Remember all the elements, it does not require to tackle all the slab. It should be resisting for the foundation. It need to be resisting air. So whenever you designing a suspended slab, don't select the second option and third option. Look at the first option, export floor loads. Go for second option, floor loads from above. When you need loads from above, when you're designing the foundation, you need entire loads. Second option, third option is both are same. Third option is what? I will have the stiffness of the vertical elements to be transferred to the foundation. In second option, you are not transferring any stiffness, only the loads. Third option, along with the loads, you're transferring the stiffness. So wherever the column's location, it will not show the reinforcement at the junction. That is the point what I'm trying to say. Point two. Same one. I have a column. Then point two. The reinforcement it shows only here till this point, because the moment is going to matter like nobody till here, right? But whereas here, the movement, yeah, even look at the columns, the movement stops here. It demands lesser reinforcement patterns. For foundation, use the third option. For slab, use the first option.
There is planted columns.
It's a planted columns in the slabs. Still don't use it like no second option. Use only the first option. Take the planted column low and apply binding. See, I have a planted column, right? Imagine I have this planted column. To make it 3D, use this goggles. Display to see the load. Same option what we did. Force, here, axial force. This is the load. I will take the 864 load, 864, I will apply manually. If you take it the second option for the suspended slab, it will take the entire load. It will take the entire load. Using the first option. Don't select for second option, third option. Because horizontal load, it will be catered by the slabs. Only the action. Action. वुमन कुछ भी फर्क नहीं पड़ेगा. Safe mat. Who did this model? There is no combination. There is no. For me, it's showing some error actually. I don't know, some error is showing. Please हो गया. नहीं, आप एक काम करो. अभी क्लोज करेगा, पूरा चला जाएगा. अभी एक काम करो, go to file, export, story as if V12. Yeah. Any story, any story, any story. Choose any story. Load cases, only the gravity. Yeah. Load combination. Only the gravity combination. First two combination. First two combination is a gravity. And okay, save anywhere. Yeah? Save. Yeah? Open the safe. Yeah? Open the safe. Yeah? Yeah. Okay. Okay. Yeah, file, import, F2K file, Open that file. Huh? Anything. This is a safety tool. No problem. Anything. It's open, right? I can run the model as it is, but don't do that. Ensure the materials and thickness and loads and combination whether it is transferred properly or not. Define materials. It will transfer in a different name. Huh? Material 1, material 2. So go to material 1, modify, change to C50, tag name. Don't need to change the density. Okay. Okay. Yeah. Okay. Then go to mat 2, modify, rebar. Okay. Define slab properties. Yeah. Leave it. It's not a problem. It's not a problem. Doesn't matter. If you do have more material, leave it. Doesn't matter. Define slab properties. S240. Modify. You do have two options here. Thick plate, orthotropic. Concrete is not orthotropic. Concrete is isotropic. Orthotropic is what actually? When you cut the trees, the roots is not very similar, right? Actually, concrete is homogeneous. Okay, so it's called isotropic material. Orthotropic, it is called non-homogeneous material. Okay, the another option is called thick plate. Thick plate is that any element, if it is resting on the soil, it is called thick plate. Any element, except the foundation, none of the element is resting on the soil. So when you are designing the foundation, make sure you need to take this option called thick plate. Then only software will understand this is the foundation. If I don't tick it, software will never consider this as a foundation. Yeah. That shell thin, you already did it in Etabs, right? Shell thin. It's a suspended slab, it is all shell thin. The thick, it is for the foundation. Shell thick. If you're using the latest version, the foundation, it is called shell thick. The normal suspended slab, it is all thin. It's all shell thin actually. Remember, we did it shell thin in Etabs. Correct, exactly. Slab is not membrane. Only columns. Direction bonum. Hollow core slab. Hollow core slab na membrane actually. Tendons than another stands tendons. Hollow core slab mattum. Okay. Okay. Design. Design preferences. Make sure the latest code has been selected. Then go to minimum cover slabs. What is the minimum cover slab? 25. Change the preferred bar size is to 12. Preferred bar size into 12. Yeah. Okay. 25. Here. Design preferences. Here. Design preferences. Because beam already designed in Etabs. Which one, sir? Forget about it, sir. Leave it. Okay. We are going to create the design strips. In order to extract the reinforcement per meter from safe, you need to create the strip every 1 meter because you are designing for per meter strip, right? Actually, so go to draw design strip. Okay, layer A is nothing but X direction, layer B is nothing but Y direction. प्लान में रखो, प्लान में रखो. Okay. Why we are putting 0.5? I'll tell you. Put it 0.5. I'll tell you what it is. Mm, 500 millimeters. Which version you're using? Tolla. Tolla. Go to draw design strips. .5 meters, in meters 0.5, because here it is millimeter. Now I'll tell you why we are changing 500. Create the line a little away from the footprint. Little away from the footprint. Go to the stick mark. Can you see tick mark? Can you see here? Another assignment, show width. Show width. Then y is 0.1. Why it is 0.5? Huh? It's a central line. From central line, 0.5 meter above, 0.5 meter below. Start end. This is the ending point. 0.5 meter above, 0.5 meter below. That is the reason we made it like 0.5, 0.5. Actually, strip to strip distance is 1 meter. One strip to another strip is 1 meter. So we drawn a central line. So from central line 0.5, 0.5. If next strip comes, it is 1 meter. So that is the reason we made it 0.5. Switch off this option, huh? Switch off. Switch off the show with option. Huh? Don't keep it. Select this line. Edit. Replicate. Which direction you will replicate? Y direction, right? Y direction, right? Every 1 meter and dy. Numbers, I don't know. Maybe the length of the building is 23 meters. Take it 22. Anything comes extra, delete it. See, for me, is nothing is extra. It is okay. 22 is okay. Yeah. Yeah. Just go to draw again. Draw. Draw. Draw design strips. Change from layer A to layer B. Change from layer A to layer B. Huh? Yeah. Then connect this line. Huh? From this to this. Again, select this line. Only this line. Huh? Edit. Replicate. X direction. Y is 0. Same 22. For me, 22 is less. Huh? Anything comes extra, delete it. 27 is okay. It's finished, right? It's okay, right? Analyze or an analysis and design. Yeah. Run analysis and design. Yeah. Keep it in 3D view. Huh? There's an option called start animation down. Huh? You will understand how the slab is behaving, how the slab is deflecting. You get a point? How the slab is deflecting. Can you see here? It is a two-way action. So it bending here and it bending here as well. Hmm. Showing animation. Only animation. Okay. It's showing only animation. Actually. But the behavior, it looks like two-way. Can you see here? The parabola curve is this direction and this direction as well. Yeah. Here it is so stiff because you have a wall. There won't be any kind of movement because you have a stiff wall. Yeah. Now go to plan view, display, deflection. We will not check it now. Deflection we will check it in the next class. Okay. Display, show slab design. Slow slab design. Here it's very easy. Huh? I'm going to see bottom rebar. Layer A is nothing but X direction. Whichever fill diagram is there, switch off because it will get confused. And right side there is a diagram is there, switch off. You need the values, right? And keep it none as it is. I wanted to know what is the required reinforcement with respect to applied load. Oh, okay. What is this? This is the required reinforcement in terms of millimeter square area of the steel, right? Okay. A little zoom. Can you see here? 570, 424, 495, 527, 535, 486, right? Isn't it? Go to display. Show slab design. Show slab design. Show slab design. Yeah. Instead of none, specify the basic mesh reinforcement from your end. Select the typical uniforming reinforcing. Change from bottom rebar to 12 millimeter dia. Change the spacing minimum into 200 millimeters. What software does? Anything more than T12 or 200, it shows extra. If it is not, it will cover up in T12 or 200 itself. Okay. Can you see here? It shows extra, right? Right? If you don't understand, repeat these steps. Display, show slab design, keep it none here. Keep it none. Okay. What is the reinforcement is required? 707,713, right? What is T12 at 200? 565, right? So 713 minus 565, 148. If I selected T12 at 200, then it has to show at that particular location 148. Then only my assumption is correct. Display, show slab design, T12 at 200 millimeters center to center, apply. It shows 148 millimeters square. Can you read it here? Bottom reinforcement intensity in addition to T12 at 200. So whatever it's showing, it's an additional reinforcement in addition to T12 at 200. Yeah. Now I can convert this bar into extra. How do I convert? Keep this table as it is. Click show total rebar, the left hand side. Total rebar. Sorry, show number of bars. Show number of bars. Change bottom rebar into 12. Just extra rebar. Apply. Every meter, I need 1T12 extra, 2T12 extra. You're getting my point. Every meter, huh? But what designer does? They will not go for T12. They'll go for the same spacing. What is the basic mesh? It's a bit of conservative approach. That's the length of the rebar. Keep your cursor here. Can you see the coordinates? Keep the cursor here. 10.3 and this 14.3. So which is 4 meters. Right? This is 4 meters. Okay. Similar way we have to do homework. I'm going to give you the exercise to do. Homework, you do it yourself. And you come back to the question to answer. We are going to repeat the same steps again for the formation. Then it will move it. Exactly same steps. Again, we're going to create the slabs. We're going to create the next step. The foundation will check the outcome reflection. The foundation will check the function. Then it will be clear. Okay. So go back and here. Reflection. Then for the use. The same steps. For you, what to do? If you have possible time, and extract the reinforcement for top, then you will be understanding. When you don't do for yourself, you will not get meaningful. If you do it by yourself, you never do it by yourself. Till if you have any clarifications, I will come back. I will clarify in the scratch. No problem.
Oh, after doing what